The next step here is to add the script to the camera so that it'll follow the ship around. There's a number of different ways to do this. Most of what I'm showing you now is just the simplest way to get it going. It really depends a lot on how the entire game's set up as to how these things would happen. You might tie it to the ship. You might have multiple cameras if it's a split screen. But for now, what we're going to do is just add a script to this camera so that it just follows wherever the ship goes. So what I'm going to do is create a new C# script as before. We're going to call this camera follow ship. Make it really straightforward. Go to the main camera, give it a second to compile, and then pull this on here. So now this is on the camera. We'll save it, and we're going to go in and edit the camera follows ship. What we're going to need is we're actually going to need a pointer to the ship, specifically its transform. So I'll make it public so that we can assign it. Call it transform, and then call it ship. There we go. The other thing that I want to actually do is create a vector, which is essentially how all positions are represented in Unity. It's a vector 3 floats, and this is going to represent the camera offset. So how we want the camera to be offset from the ship itself. So that's what that's going to represent. So we don't actually need a start function. We're not initializing anything, so we'll just get rid of that for now. And in the update, all we're going to do is do transform. That's the camera's transform position equals the ship position. And there we go. So every update, every frame, it's just going to move itself to where the ship is. So the only other thing we'll have to do to get this to work is to make sure that the camera has a pointer to the ship object. So we're going to click on it, and you'll see that it's not assigned. And we're going to put that on here. Actually, I just realized there's one other thing we have to do. I'm going to set this to 10, which is the same as what this is right now. And I'm actually have to go in here, and we're actually going to have to add the offset to the ship position, because we want this camera to be the ship position plus the offset, which will be this 10. And these two will just be changed to whatever the position of the ship is. So let's see how that works. We still have our ship as our old values because we didn't update. So let's set this to 300 and let's say 200 just to give it some values. So now we're moving around. You can see that our position is changing, but since there's no objects in the scene other than us and the background's pretty much static, you can't really tell that we're moving because we have nothing to show the relation to. So let's add a few objects just so that we can see some things in the scene that that can move around as we move around. So I'm going to add a cube. Just going to 0 it. Let's see, maybe make it half as big. Now, right off the hop, this isn't actually going to do a whole lot as far as from physics perspective. It's just a block that we can fly through. There won't be any physics involved. So I'm actually going to add a rigid body so that we can collide with it, because that'll be a bit more fun. And there are different types of rigid bodies. A regular rigid body will interact with everything and be moved around. But if you set kinematic, it's essentially set in stone or fixed like an anchor in the universe. It won't move at all. So if we change that to is kinematic, we can basically have a really hard surface we can attach to, or sorry, hit against when we're flying around. So let's do that, and we'll do one at the -2 just for variety. I'm going to move that. So as you can see, we have two now, one on each corner. They're both kinematic and in place, so we'll save that and see how that looks. Oh, and I still haven't set my, I should really do this so I don't have to do it every time. All right, so now you can see we're flying around. You can see the blocks, so you can kind of see that we are moving. And when we run into them, we just bounce off them since But you can see there's actually an issue here. You can see that our ship is rotating in really bizarre angles. And the reason for that is that the um, we fixed the X position, but we actually haven't fixed the other positions. So in order to do that, what we need to do is go back and change some of the default values. So here, we don't actually want to be able to rotate on the x-axis, the x-axis and the z-axis. We only want to be able to rotate around y. So I'm actually going to set those. I'll also set this to the default values that we found were working pretty good, and that should stop us from rotating when we collide with things. Yeah, so now we can rotate. There is a bit of an issue. I seem to be spinning out of control here, and I have to fight the other way, so we'll take a look at that and see what could be causing that. The rotation is set by the ship controller script, so we're going to go in there, open that up, and check out our rotation code. So right now what we're doing is just setting the rotation, but the problem is that when we hit things, we get an angular velocity, which we don't really want, not for the gameplay that we're trying to achieve. So what we're actually going to do is always take, before we make the change to our rotation, we're actually just going to take our angular velocity and set it to 0, because we want to kill any of the rotation due to physics that we have set before we set our fixed position. And that really comes down to gameplay mechanics. Sometimes in games, or most times actually, we don't need a perfect simulation. What we need is the fun factor. We need to tweak it, we need to change it until we find what's fun. And in this specific circumstance, fighting the angular velocity when you're trying to fly around isn't really fun. So what we're going to do is just eliminate that so we have maximum control, and we can focus on other things as the challenge, like the opponents or other things like that. So now if I hit stuff, yeah, I should be able to bounce off of it and move around and fly around in space doing different things. So that looks like it's working properly. There are a few other things I would like to do, because right now technically I can fly and go any amount of speed. It's just going to keep adding and adding and adding forever until my velocity is just at a ridiculous pace. So what I'm going to do is implement some stuff for maximum velocity to make sure I don't go too fast. And also, if I'm going too slow, it just stops me completely, just so I can stop if I'm stopping. Now, the only way to really stop right now is to counter the direction I'm moving. But I'm actually think I'm going to put in a backwards key, the S, to brake me, kind of like space brakes. Doesn't really make sense, but we'll do it just because it's fun. So I'll try that stuff now. Okay, so the key that we want to do for backwards is going to be S. So we're just going to copy and paste this, change this to S. And what we're going to do here is make it so that when we're want to brake, it's actually going to be slightly different. We don't want to add a force, because it would be a very gradual brake, which would be interesting, but not nearly as fun and as fast paced as making it so that it brakes faster. So what I'm actually going to do is do its velocity times equals, let's do brake multiplier. Now this doesn't exist yet, so I'm just going to create that as well and set that in there. Do this correctly. Okay, so now we're just going to multiply it by a brake multiplier whenever we're holding S, and that should slow us down depending on what we put in here. So the ideal number is going to be something that's really high, because it's going to be multiplying quickly. Anything that's lower than 1, like let's say 0.1, would essentially immediately stop us at all times. So what we actually want to do is something really high, so it's a bit more gradual. So let's try 0.8 to begin with and see how that works for movement. That works pretty decently. It stops us actually pretty fast. So if we go back to this, and let's say break 0.98. This actually was 0 before. The reason for that is because I saved it and it was 0, so it created with a 0, and then when I changed it, it hadn't updated. So let's try this with 0.8. It still is pretty fast. Let's try 0.95. Yeah, it's more of a gradual break, which is interesting. I think I'll leave it like that for now, 0.95. So I just have to go back, set that so that it's like that in the future. So now we have some breaks. So now let's switch over and set some maximums. So what we really want to do is have a maximum value that like a speed that the ship can go. So what I'll do first is set that float max velocity. We're going to start with 10. Let's see if that works. And I'll spell float properly. Here we go. So what we're going to do, in order to figure this out, what we need to do is take the ship's velocity, which is actually it's a vector, so it's two angles, as y is always 0. So we're going to take the rigid body velocity. So let's see here. So what we're going to do is call it, let's make another one we're going to make another float that represents the ship's current velocity. We're just going to set it to 0 for now. And here what we're going to do is assign it to the rigid body dot velocity dot magnitude. Now what magnitude does is it tells us how much, it essentially combines the two vectors to give you the magnitude of a vector. It's a math related thing, but the way that it works is you combine x and y, or x and z, whatever it happens to be, into a number, a single number that represents how much that is. So after we have that, what we can do is check to see if it's greater than the maximum. So we'll take the ship's current velocity as long as it's, or actually if it's greater than the max velocity, then we want to do something, which is to set this, let's see, I want to set the velocity, the ship's velocity, to the ship velocity normalized times the max velocity, wherever it went there. Just copy it. So what this does is first gets the current velocity, which is just a number representing the magnitude in the direction you're going by combining the two x and y. It would do z2 if it wasn't 0. Checks the current velocity, sees if it's higher. If it is, then it sets the ship's velocity to the normalized value times max. So what the normalized value does is take the x and y and makes it so that the magnitude 0 and the x and y match. So let's say your magnitude was 10 and you're going at a 45-degree angle, then your both x and y are probably going to be 5 and 5. But what normalized would do is make it so that the magnitude would be 1 and then x and y would be 0.5. So if you multiply that by the max, it essentially gives you the same direction but at that max velocity. So that's essentially what we want, and we'll see if this works. It should stop us from going any faster than a given amount. It might be hard to see just based off position and numbers, but it should play out as making it so you can't go faster than a certain speed when flying the ship, which will be good.